not for me.
Testing for now. Why am I seeing someone else's stream? I have no idea.
I do need more.
Oh my god.
Jesus!
Okay. Great. Now double checking if it works on Twitch. My channel. Horrible echo incoming. Horrible echo incoming. Okay, horrible echo incoming. Okay. Sounds good. Looks good. Okay. Get my channel link. Fine. Done. Okay. So weird that I don't see my own chat. Refresh chat. Accept. Okay, great. Now ready to do some good stuff. Okay. Hello, Taylor. Hello, everyone. Hope I sound nice. Hope there is no noise. Hope I look good. And many other things. So today and in the future lessons, I will try to change my strategy a little bit and focus more on live coding and completely drop the slides, because that's the format I think which doesn't work. So for today's lesson, the essence is in this wiki if you want to read on your own time. But I will try to live code everything from scratch. And I'll try to be slow and explain everything so that you guys understand. All right, let's get to it. So today I would like to talk about two patterns, builder and decorator. So I will start from problems, because it doesn't make sense to just give a solution to something that you don't understand. Why does it exist? So what problems are we solving? All right. What problems are we solving? Let's first create an object, right? So a complex object, for example, a house. It's a very classical example. Oh, you see Battlefront? Well, that's amazing. Fuck. Oh, no, 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 that's bad. Sorry, guys. Remove. Yes, now it's black. That's good. Give me a moment to add a new source. Desktop. Window capture. Fuck, no, I don't remember. That's so weird that it didn't appear. Video capture device, window capture, display capture, primary monitor center. Yeah, that's the one. Okay, now you should see it fine. Do you see my screen? it's also awful. That's pretty bad. It's not too much full screen resolution. Yep, we can see, but we can't see you because super zoomed in. Yep. Okay, so we'll play around. Sorry about that. Transform size 1920 180. That looks good. And if I move these guys ahead, that looks also good, right? That's also a unique experience because not always you will see setting up the stream live on stream, which is okay. Okay. Is everything okay now? You can see Visual Studio, no delays. I'm zooming in now and everything is fine, right? I'll wait for confirmation before I continue, so please let me know. Okay, so imagine that you have a complex object such as a house. And a house actually has multiple parts and some parts are optional. So imagine some houses have a garage. We'll focus on those optional parts. So I'll just stating the scenario with comments. House is a complex object. It always has a wall, roof. It may have a garage, a swimming pool, etc. So that's what we will try to do. We will try to allow easily to build house with both mandatory and optional parts fluently. Right, so I will simply define those parts. Imagine that those are classes. In reality, they would be classes, but I will simply call them strings for now. Doesn't really matter. So private, read only. It will be actually public, get only. We will set those once. So public string, and I start wall. Public string roof. I'll simply define properties for the things that I just mentioned. So house has wall and roof, those are mandatory. And then optional parts are garage and a swimming pool. So those are optional. Now, since wall and roof are mandatory, I'll pass them through constructor. So I'm doing just that. I'll do it like this. So what about garage and swimming pool? Actually, a house can have multiple of those. So a house can have either 0 or many. garages or swimming pools. So I'll change slightly. Garages, swimming pools. That's fine. How do I make it extremely easy to set it up? Well, first, I'll make it not so easy. So first, just the situation. We have swimming pools, we have garage, we have house, roof, and wall. Okay. It's fine. Let's make it a get set. Like, these can change over time, which is fine. Okay. For now, this is good. So we have a house, plain stupid house with wall and roof, with walls and roof. Potential with garages and swimming pools. But potentially not. And now we will move to the illustration of an actual problem. So how do I add garages or swimming pools to that object? So what I could do is do a demo. So let's create a new house with a simple wall and with standard roof. Now to this house, we will add a garage, let's say, a small garage. We will add one more garage, medium garage. And actually, when adding a garage, I would like this to also, be separated, maybe by a comma, maybe not. And let's do the same with swimming pools. Medium swimming pool. The problem here is that I can't really do anything I want with this. I can actually say that garages are suddenly empty. Sure, I could use a string builder, but that's besides the point. The problem is that this is not very convenient. Why is it not convenient? Because, I mean, this code is hard to read, and it needs to make me think. It needs to make me think, what am I doing? How is this useful? And I can break this pretty fast with this, for example. Therefore, instead, what I should be doing, and again, another problem, I keep calling house, 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 and then garages, concatenating strings. This is not very viable. It's hard to read, and it's redundant. So, let's solve this problem using a builder pattern. The key point to a builder pattern is that we are not supposed to be changing the thing that we're building. I mean, the code of this class should remain untouched. The thing that we will be changing is how we build different pieces. So outside of this class, we will create another class called house builder, which will build a house. So let's try to do that. let me know if I'm too slow or too fast. A house builder. A house builder builds a house. So I will have a private instance of a house, the thing I will be building. Private. Actually, I will not yet. I will have every single property that this guy has within the builder. Since I know that garages and swimming pools, there could be dozens of them, as someone already suggested, I'll be using string builder. And these will be fields, I will not expose them. So I will make everything private. Right? I'll make everything private. And I will start a house builder similarly like a house with walls and roof. And this will set walls and roof. This is okay. This is nothing special. But now I will add a few methods that will help me with adding extra details to this object. So to garages and swimming pools, how do I add them? So actually, I will be using a list instead, because it will make my life easier when I join multiple elements in them. And this is definitely getter and setter is not needed. Pools. Instead, I will initialize them here and here. So now the essence of builder is that I can add elements to this object, or at least parts to that object that I'm about to build. So what am I adding? I'm adding, again, a garage. So garages. And I will also add a swimming pool. The same mythology. Now I have two parts which I added to my house builder. Or rather, two methods which allow me to add parts. By itself, all of it is private, and it's not very useful. So what do you think a builder is lacking, guys? What method do you think a builder should have? A builder should do what? Build. In general, if a house builder builds a house, you don't need to be so verbose. So all you can say is that I'm building a house. So build will return a house. And actually, it will be really, really simple how I return a house. So I'll just return a new house with the walls and the roof and the garages. with like all garages separated with a comma. And I will do the same with swimming pools. And this will be what my build method returns. So if I do a demo now, my solution will look a lot better. So my solution now looks like this. So I start from walls on a roof. I will actually copy paste this one so that you guys can compare in parallel. Whoops. Right. So simple wall, standard roof. House builder. It's Star Worker, it's a builder pattern. I am creating a house with optional parts and adding those parts for a builder, and then in the end building the house with a builder. So we add a garage, small garage, and the key point here is now I no longer need a comma here because it's managed by the builder itself. And if, let's say, I wanted to delete garages, well, I wouldn't be adding them in the first place. So I cannot even remove garages anymore, which is another benefit. Swimming pools. Add swimming pool, medium swimming pool. And then the actual house is here. In general, more readable, a bit more code, but more readable. But that's not all. So could be better. Why could it be better? You can see that house builder actually is repeated 1, 2, 3, 4, 5 times. Could we do something about it? And the answer is yes, of course. Not with extension methods yet. We will be talking about them today, but with a different thing. Yeah, we will be chaining. So Fluent API is another thing I wanted to show you guys with the builder pattern. Builder pattern is the best example of how you can create Fluent API. So if a function call doing something, if after doing something, it returns the instance which called that function, in other words, this, if that function returns this, it means that I can chain call it how many times I want. So instead of creating a house builder and then calling it multiple times through its instance, I can chain the calls. So fluid chain of calls. So here we go. I will do the exact same thing, but with a little bit of magic now. Remove, 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 remove. And instead of those house builders, I can remove them just like that. So you see how much code suddenly got removed. No more house builder calling explicitly, because each of those methods returned the house builder itself. So I add a garage and it returns the house builder. I add a garage, it returns the house builder. I add swimming pool, it returns house builder. I call build and then it returns the actual house built with all those things inside. So let's just implement the string. Maybe I can do at the string like this with resharper. Nope, didn't help. Okay, so I'll just print all the parts now of this house. So right, walls, roof, garages, and swimming pools. And if we go back to the demo and print this, we will see that the pattern worked, which we didn't because I'm not calling the demo yet. So you can see simple wall, standard roof, small garage, medium swimming pool, which are all the things that we added here. So builder pattern allows us to solve two problems essentially. Create Fluent API for method chaining, and on top of that, create a very human readable way of adding optional parts to an object. If I didn't have a builder, I would need actually, well, to struggle like I did here, or to work with different things. It's not very viable to solve this problem like this. It's not readable and it's easy to break. With an API which I control, I can make cool stuff. Another benefit that I just won with this, I can now make these parts immutable, actually. Or I could make them internal and only touchable by the builder. So the builder could be the only thing that can touch those things. Let's say a builder and the house are in the same assembly. So builder is the only thing that could touch the garages and swimming pools and construct them fluently. Okay. There are two variations of a builder pattern. So one variation is here where I work with a builder which has all the parts. Another variation could be is a builder which takes a house and adds stuff to it. So here is another builder. So here I will start from an actual house. Swimming pools, I'll just do something very simple. Sure, I could add rooms and other things. I'll add garage for simplicity's sake. Garages. Garage. Of course, there should be like to do, determine if comma is needed. But we won't be doing that. There is no point yet. And again, we will be returning this, which is this thing, v1. v1, v1. Okay. And swimming pools, the same thing. Cool. Swimming pools. Swimming pool. Like this. Okay. And now building will not create a new house from scratch, but instead it will be just a matter of returning the same house that we are decorating. Or in fact, we wouldn't even need to do anything about it. We could. There are actually two things how it could work, but build method sometimes can simply return the instance that we are working with. Okay, so in this case, we could say that we are building the same house. v1, and we pass the house that we are about to decorate with parts. So we add a garage. We add a swimming pool. And we build the thing with those additions that we've just added. And if we print it again and run the code, you can see that it didn't work because I failed. It should have been plus, and here it should have been plus as well. And here you can see that the first house had these things and the second house had these things because I was decorating it with extra things. So there's a little variation right there. And last variation is standard house builder. Last variation is, imagine that there was a possibility to create template houses. And this thing is called a director. So we will always be creating houses the same way. That's how it was done, let's say, in the Soviet times when, for example, Lithuania was a part of it. All houses look the same. That's how they did it. So let's do it how they did it. Public void, a public house build. It's actually called direct, but doesn't matter. So we will be creating var builder. Plain gray walls, red roof, brown roof maybe. Small garage. Small swimming pool. Build. So we have a house and we return that house. So that's another variation of houses. Like imagine that we could build standard houses all houses look the same. So we could we could be building houses in a standard way, like this. Standard house builder dot build. So it defines a fixed flow how a house is built, and it applies the same parts for every build it does. It's common sense for this one, but the problem with this part of this pattern, of the builder pattern, is that it is almost always mentioned. Director is almost always mentioned as a part of a builder pattern. To me, it's just common sense using it in this way. So I wouldn't like mentioning this so strictly. Like, it's optional. You can do this, you might not do this, and I think if you had to do this, you would figure it out anyways. So it doesn't matter that much. But the builder itself, remember these things. Remember how a builder can reduce the amount of variables, like the instance calls, and at the same time, you can fluently add stuff, optional stuff, and control that very well. And create objects, read-only objects, by adding optional parts, regardless of those objects being read-only, as we did with our house, which was read-only, kind of. Okay, it could be read-only and nothing would change. So those are massive benefits. If I run the demo again, you can see gray walls, brown roof, small garage, and small swimming pool, how it was built with a standard house builder. Okay. There is one more thing, one more problem which a builder could solve. So I will create a different example. Let's say we have a gift. And gift will, the only thing a gift will have is content. That's it. A very stupid object. Could have more things, but for now we will limit ourselves with this. So yeah, it's not even like a very useless example of this object, but just imagine an abstraction gift, and inside the gift, well, you can see what's inside it. Maybe let's make it a bit less stupid and just have a person as well. Recipient. It's not that kind of a gift which has, you know, like an actual person or a doll or whatever inside it, but it's a different kind of gift where, well, you have nice things, and this is to whom you send that gift to. It doesn't matter much, but you'll see what I mean soon. So what problem am I seeing here? Let's remove that. The problem I'm seeing here is, imagine I have a bunch of methods which decorate gift with different contents. For example, private, static, void, add, item, string, item. Private, static, void. So what I'm trying to, what makes sense to be done with a gift? Well, gift. We might want to add an item to it. So what does that mean? That means that the content is now item, item. We could also add a ribbon on a gift. So we will set the color of ribbon. Again, that will involve doing a very similar thing. Right, color the string plus ribbon. Okay. Next, we might also want to add packaging. And again, we will use a color. What color is our packaging? And the problem here is that if I create a gift, and I call all those methods, you can already spot that a gift is repeated in every single call. And builder, again, is the thing that would come to our rescue. So I would have gift builder. And I'll simply move all those methods into gift builder. So I will again have an instance of a gift within my gift builder. Like this. I will remove static modifier. Instead of void, I will return my own instance so that it's fluent. And I can now remove these arguments because I will feed this argument through a constructor. So underscore, underscore, underscore. Great. And return this thing. Literally this thing as in the context I'm at. Gift builder, doing the same thing. And the magic is that now, instead of doing this, I can now do this. So I just start from a plain and stupid gift. But I can make it not so stupid with a builder. I forgot to expose those methods. Give me a moment. Public. Add item. Socks. Pikeman said, I think there is a design problem with this code. Please let me know what you mean. Color. Thank you. It has been quite well. I've been having pretty good time. I was actually teaching Java. That's why I was absent. I was teaching Java in a private boot camp. So this essentially does the same as this, but the benefit is that we no longer use gift for 3 times, we use it only once. We can go further and make this slightly better by having an empty seater and creating a gift in case there is nothing here. So if I do this, I can actually do it slightly different. And again, I'm missing a build method. Public gift build. So if I go here, sorry, if I go to the demo, and I no longer need this, and I no longer need to say that this is a builder because it's a gift. If I don't pass a gift, and if I build, it will return a gift. And let's just override the contents. I will soon reply to the discussion. It will just say content, whatever. So if I run, it says item socks, aqua packaging color, and chocolate ribbon. Okay. Cool. So Pikeman said you have a private member in gift builder gift passed into seater. So that means you can modify the private state of the gift builder. That's right. That's a very good point. I think it would make sense to make gift public if this is how it is intended. It's an interesting point, and I definitely cannot say I disagree. The only thing the only thing why I didn't do it, so basically what you're saying that instead of, I get you. I agree. I probably agree. You're basically suggesting this, which I agree. In this case, I probably agree. But in the other case, in the method of build, I still agree. It will still be a gift in the end. So I agree. So instead of build, I can now just return gift. Fair. 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 Both ways work. I think this variation can definitely work with just a property, a public property, read-only property. Yeah. It's less code in the end. So I would agree with this variation. Yeah. Cool. Mystic Soda asked, what's the difference between builder and pattern? That's a great question. So here's the difference. Builder builds one object. Factory creates multiple different objects. I hope this answers your question. So with factory, there might be different types of objects that I built. But with builder, there's only one. I'm very focused on building houses. I'm very focused on building toy soldiers. But with factory, I can build either roofs, rooftops, windows, doors, and many objects. So practically, how could these two be combined? A builder might use a factory to help with initializing different parts. A factory can be used to create different types of objects. I didn't really explain that well. So builder will build a house. Factory will create doors, windows, bricks, etc. So builder is very focused and it works on one object. Factory usually creates multiple different objects multiple times. Builder can also create an object multiple times, but it needs a little work for that. In order for a builder to create an object multiple times, it needs to be reset in the end. So for example, let's house builder. Let's say our method build returns a new house. Yeah, so before returning everything, it should also reset everything. Private void reset. So in this way, if we want to reuse a builder multiple times, we should be resetting stuff. And here's what I mean. Let's comment this out for now, and let's go to where we called this. So let's say we have a builder. Practically, that's also a very good example of a builder. Let me think if that's a builder or not. It is a builder. You're adding parts, optional parts, dependencies to your service collection. So it's a builder, definitely. Actually, I resetted those. I resetted too many things. I'll keep walls and roofs, but my garages will be reset. Okay. So if I do this, and if I do build a few times, I'm just trying to introduce it to a slightly different problem. So ASD, BSD, whatever, build car house. Let's call it house 1-1. So here we built a house. And here we'll build another house. And you might think that this house, these two houses will look exactly the same, but they will actually be very different. Because the first house and the second house, they were using the same parts. So swimming pool, I mean, these parts were added twice because I didn't reset the builder. So to make it reusable, if I plan to assign an instance to a builder, I should be resetting it after building. So if I uncomment this and run it again, I messed it up because I should have created new lists and not nulling them. So I should instead be just clearing the lists because they're not strings, they're lists. Okay. So as you can see now, it works. It works simply because we reset after we build. So there's one more thing to take in consideration. Pikeman said, when talking about factories, usually the thing that is referred to is abstract factories, I think. I think if you are in a context of design patterns, I definitely agree. So the problem which abstract factory solves is that there are multiple hierarchies of objects. So you can choose. So one factory manages a single branch of those objects. For example, you have Mac and Windows computer parts, for example. So Mac will have its own I desktop, I monitor, I HDD, I SSD, I RAM, and so on. Windows will have its own I Win monitor, Win HDD, Win SSD, Win RAM. When Mac is built, it will use I parts. When Win is built, it will use Win parts. So that's abstract factory. What's it for and how is it different from the other things? Let's move on to the decorator pattern. And I have an example so that I don't forget what I wanted to illustrate. Imagine there are three behaviors or many behaviors. Like it needs to be at least three for it to make sense, for it to be practical. There are three behaviors, and we will be using logging as an example. You can print text to a console, you can pick a color before printing, and you can authorize beforehand. So these are three behaviors for logger, let's say, or a printer, not necessarily logger, but a printer. So what's wrong with this printer implementation if you need to combine all three things? We have a basic printer which prints text to console. We have a printer with color which does the same, but before we do any printing, it asks us to pick a color. And finally, we have a printer with color and authorization, which asks user to input username and password before the actual printing can be done. So we have three things which incrementally do a little bit more. What do I mean by that? Let's run a demo. So public static void demo. Var printer, new printer, like this. Printer, print. Hello world. So if I go here, and if I go to problem.print.demo, if we demo the problem, you can see we're authorizing, we're picking color, and we're saying hello world. Note that in this case, these are really trivial things, but they don't have to be trivial things. You can literally replace this with verification of username and password or any other authorization method. You can replace this with user input reading from the console easily. And this, well, this is actually functional. This could be sending stuff to an actual device as well. So regardless of this being absolutely stupid, if you were to replace behavior of these methods, you could add whatever complex behavior you want. The key point is not each individual part. The key point is how you combine different parts to work in unison. So the key point here, we used inheritance to add behavior and it worked, but we are kind of stuck at a certain point. Here we had a printer with color and authorization. Here we had a printer with color. What if we wanted a printer with authorization, but not necessarily color? And at that point, inheritance fails us, because we could model another chain with all the things that we would like to inherit, but that would cause duplicate code and essentially would cause an explosion of classes, because for every combination A, B, C, A, B, A, C, B, C, A, B, C, and so on and so forth, we would need another class with inheritance, like you can see here. Not a viable solution. And this problem is solved quite elegantly using Decorator Pattern, which we will create right now. So I will start from the same thing, a printer. A basic printer which can print text to console. That's a basic printer, as simple as that. I will continue with another printer which prints with color. So we would pick a color. So I will just rename this slightly different for now. you'll see how it all eventually comes together. And lastly, the one with authorization. Obviously, since these are three distinct behaviors, there needs to be three distinct components. And what we want to achieve is no duplicate code, no combo classes. We want to fluently combine everything into a single component, which just works. It makes sense. So, how do we call this method in this method, or how do we add behavior to this method? How do we add picking color and authorization if inheritance is not the answer? What we need to do is, well, obviously we will be using this component somehow. So we need to have it here. But if we were to use this component, since this component and this component have nothing in common yet, we will be in trouble. So we first need an interface which each of those will implement, because they are all printers, just a different kind of printer. So a printer implements this thing. That's fine. A printer prints. A printer with color also prints. But how does it print? That's a very good question. It prints by first picking a color. But what should it do next? It should actually call the implementation of another component. So the key point of Decorator Pattern is that it has an instance to the same thing which it implements. It has instance of the same thing that it implements. So this is the thing which we decorate, we pass through constructor. Extra and the same. So with Decorator Pattern, we hold an instance to the thing which we decorate. And when doing the thing that we're supposed to implement, we first add extra behavior and then do the thing which the thing we're decorating does. So again, we add extra behavior and then we execute the normal behavior on top. Picking the color. Okay. And here we will do the same. And actually, Now, picking color no longer needs to be public because the only thing we want to expose is print. All right, and let's initialize it and let's repeat the pattern. So the pattern again, the thing I implement, I hold an instance of, and then I just call the base implementation, well, add extra behavior and call the base hello the Z-man. Very, very simple pattern. Extra behavior, do the same thing. Extra behavior, do the same thing. If you put it in the end or if you put it at the start, it doesn't matter. As long as you put it somewhere and as long as you recall the same thing. Cool. How does that work in practice? If we go here and create a demo, with a method run, if I create a printer, that's fine. If I create a printer with color, that's also fine. I just pass the same printer. And then if I want to decorate one more printer, and with oath, I will create that too. So if I do the actual print with the last printer, you will see that it will work. Oops. Okay. Decorator. Yes, please. Oops. Why is it not picking up? Problem. Using static. That's a very good point. Thank you. No, not using static, or maybe using static. I'm a bit confused at this point. No, there isn't need for that. It should pick up. Oh, right. The demo itself. Actually, I don't know. I still don't know. Oh, wait. I'm still confused. Demo, public static class demo in this namespace. Hella confusing. And how is... Oh, right. Solution. Right. Okay, makes sense. I forgot solution. So, as you can see, if we start with a plain with a plain printer, and then we add color, and then we add authorization. First thing will happen, the last thing that we did, and then the one in the middle, and then the first one. So we authorize, we pick a color, and then we say hello world. That's decorator. Like if we called all three things, hey color, hey with auth. You can do that too. And now I can say hello world with auth, and then you can see hey color. The two printers did incrementally more stuff than the basic printer. So that's the essence of decorator. It allows us to decorate a basic class with extra behavior. It doesn't have to be basic, but it just incrementally adds behavior. A very good example, a whole bunch of loggers are implemented this way, where you can just provide different sources for logging. You can log to console, you can log to database, you can log to file. There's so many ways how you can do logging, to debug, and so on and so forth. So very useful, practical and useful. However, what is less practical and useful is how you actually create those combinations. This is very difficult to read, especially if I put it all in one line. How do I manage the creation of these different combinations? You might think that Builder is the best solution, and in fact, it wouldn't be so bad. With Builder, I could build printers quite fluently. It will be nice, but there's a better way, and I'll show you that better way. I'll call it printer combinations. It'll be a static class. And here's the thing. We will use extension methods to create combinations for a printer. So here goes. I will use Fluent API on top of this. So we will be returning iPrinter. And we will say that we'll have iPrinter with some feature. For example, with color. What does that mean? So to what are we making an extension? Well, we're making an extension to iPrinter because we want to decorate iPrinter with behavior. So here I create iPrinter with color. I'll create one more extension method with auth. Which looks very similar. How is this any more useful than what we had before? If I go to our demo, I can remove these now. Kind of. Well, I'll comment these out. And instead, I will create a final printer fluently. So instead, now I will do this. Very similar to Builder. With auth, with color. Auth is the other one. Okay. Like this. And if I do printer print, you will notice that the result is exactly the same. However, readability of this and this is ridiculously simplified. So extension methods are an absolute best way of simplifying decorator, I'm sorry. The building of decorator combinations. It's the absolutely the most fluent way possible of creating combinations of decorator. Fluent API and all the ugliness is encapsulated, abstracted away from the user, the consumer. And that will be all that I wanted to talk about this time. What do you guys think? Do you have any questions? Did you learn anything useful? I will push this code. Oh god, awful. My computer name leaked as well. Okay. That's good. Okay, I'll push this after the lesson. Well, I actually think I do have it hooked to my account. I think so. Okay, anyways, let's name this lesson 5 demo. Or rather, yeah, lesson 5 demo. Commit and push. Done. Sign in for browser. Authorize. Confirm. Authentication succeeded. Pushing. Nice. Okay, so that'll be all for this time. Thank you very much for your attention and see you next weekend. Bye bye.